Hello, in this video, we will be seeing how to check if a given 2D array is a valid Sudoku input or not. And we will be building a solution in JavaScript and also compute the time complexity and space complexity of the solution that we will be building here. Before jumping into the solution aspect of it, let us first understand what the problem statement is. Let's say we are given a 2D input that looks something like this. We have numbers represented from 1 to 9 and we have these dots represented blanks. What we have to see is that there are non-repeated numbers in each row, each column and each box within this input that we have received. To further elaborate, what that means is something like this. Let's convert this representation into a box representation that would look something like this. So we will say that represent whatever input you have received in this 2D array as a 9 by 9 box, and each box should have non-repeated numbers from 1 to 9. Then it's valid. Each column should have non-repeated numbers and each row should have non-repeated numbers. Then only we can say it's a valid Sudoku use case. And it might be that the current input that you are given might be unsolvable, but the core of the problem is that whatever input we have within this 2D array so far has to be valid. We don't really care about what it will be in the future once we start filling the matrix further, but with the given input we have to make sure that in the rows it is from 1 to 9 non-repeated, in the columns 1 to 9 non-repeated, and in each boxes having this 9 inputs that has to be non-repeating. And that's pretty much it in terms of the problem statement. Given this input, what we will do is we will try to reach a solution using sets, wherein we will keep track of these numbers that we are encountering as we iterate through our input that we have received. And if we encounter already encountered element in this set, then we will say the Sudoku is not going to be valid. What I mean by that is something like this. What we will do is represent whatever input we are given into sets, and these sets are going to be, for each row there is going to be one set, and for each column there is going to be one set, and for all the boxes that you have, each box is going to have one set. So the representation that I have drawn here looks something like this, wherein you have a set per row that you have, a set per column that you have. By set I mean a hash set, and a set per each box that you have. So you have 1 2 3 4 5 6 7 8 9 boxes, and for each box there is a corresponding hash set that we will be using to reach a solution. Now let's jump into how we will solve this problem statement. We will start from the top left. We will just keep iterating through the entire row through its columns. Then we will go to the next row and we will cover all the rows that we are given as input. So I will start with the first input element that we have here, phi. This phi, I will say in my row, I will check if in my row corresponding, the corresponding hash set that I have, if that element exists or not. If it doesn't exist, all good, I can continue. I will just put the element in my hash set and I will continue. Then I will move on to the next element. Before moving on to the next element, I have to cover everything else that has hash sets also. What I mean by that is we have hash sets for rows, I have hash set for columns, and I have a hash set for the boxes that I have also. So I cannot just directly go forward and say that just move on to the next element. I have to go through all the elements that I have and try to cover and fill the hash sets corresponding to them. What I mean by that is I covered for the row and I put the corresponding value in the first hash set, which is associated with the first row. Similarly, for the first column that I have to also check, is this set having the element phi in it? If it has, then something is wrong and it's not a valid Sudoku. If it doesn't have, all good. I will just put it in my hash set and move on to the next hash set, which is for boxes. So in the corresponding hash set that I have here for my first box, I will check if phi is there. Phi is not there, all good, ready to proceed. So I will put phi in the hash set and I will move on to the next one. And I will repeat this pattern throughout my entire input that I have. So I will go to 3 here, 3 is not there in the set, all good. I will check corresponding column set for this 3, it's not there, all good. I will check in the corresponding box, is 3 there? No, all good. So I will just put 3 there, then I will move here. If I encounter a blank space, that means it's not yet filled and I can just safely ignore it for now, because we only care about the input that we have been provided. And similarly, I will just move forward. I will move on to this 7. I will see 7 is not there. I will put 7 in its respective column set. I will put 7 in its respective box. I will keep moving forward. I will reach here. I will move on to my next iteration. That is my second row that I have here. So I will see 6. 6 is not there. All good. I will put 6 in the corresponding hash set. I will put 6 in the corresponding box hash set that I have. Keep moving forward. And this is empty. I will reach here. I will put 1 here. I will put 1 in the corresponding hash set against the column that I have because it doesn't exist. I will put 1 in the corresponding hash box that I have. And similarly, I will just keep moving forward. For 9 also, I will put 9 here. I will go here. I will check on the corresponding hash set that I have for 9. I will put 9 here. I will check against the corresponding box set that I have, and I will put 9 here. And I will keep repeating this process towards the end until I see that I have found any repeated element. If I see I have found repeated element in any of these hash sets, that means it's not going to be a valid Sudoku. And this is pretty much the implementation strategy that we will follow to reach a solution. And in the end, if you don't find anything that is repeating, you just return true, which in this case happens. And once I reach the end, it's going to be that I'm not going to be finding any repeated inputs within any of these hash sets that I have of these 3 categories, which is row sets, column sets, and box sets. And in the end, I'm just going to return true. And that's pretty much it in terms of the solution criteria. Now, what we will do is convert this into code and see how it looks in terms of implementation in JavaScript. So what we will say is something like this. I will start with 3 types of hash sets. One type of hash set is for a row that we had. Another type is for the column sets that we have. And another type is for the box sets that we have with us. So 3 types. And in this input, we said that we have to make sure that the input is from 1 to 9. So maximum you can have 9 numbers. And similarly, you can have just 9 boxes at most. 9 rows and 9 columns. So I will say my n is going to be 9. And in the end, I'm just going to return true if I don't encounter anything that is repeating within the set. That's what we said. And I will be iterating from the 0th row to the last row, which is going to be having the length of n. And I will just keep iterating throughout its entire length. And for the columns, I will use a nested loop. I will say c is equal to 0. C is also going up to 9. And I will just keep incrementing c. And within this, I will put my checks for seeing if it exists in my corresponding hash sets or not. Now it's time to create my sets that I want to have. So I will say for the row sets that I want to keep, I will say create a new array up to 9 and just initialize sets inside them. What I will say is map, and within this map I will say return new set, and that will give me for each row corresponding sets that will be used to keep track of their respective rows. And similarly, like we did for rows, we will also keep sets for our columns. So I will say, instead of row, just column set. And in terms of the last aspect that we have to take care of, which is our box sets, I will also keep another tracker for them. So 3 types of sets corresponding to the rows that we have, the columns that we have, and the boxes that we have with us. And with this, I will iterate into my loop, and the first thing I will do is try to capture the value that I have received. So within this board is going to be the input that I receive, and I will say the value is going to be something like both of the row and the column that I have. And we also said that if you encounter empty, just skip the loop. So I will say if the value is going to be a dot, which is going to be received as input if it's empty, I will just say continue from this loop. So you just skip that iteration and go to the next iteration. And now comes the logic part, wherein we said we will keep filling this sets with the values that we encounter. So we said that whatever input you have received, which is going to be the value in the current iteration, we will first check it in the row set. So we will say if our row set has that value, that means something is wrong. You have already encountered this element in the past, and this cannot be a valid Sudoku. So I will just return false if I have encountered it. If I have not encountered it, then I will just put the element in my set. So I will just say row set dot put the value that you have. Now the interesting part here is I cannot just put within the row set, because the row set itself is a array of multiple sets. So I have to put it in the corresponding set that I want to put. I cannot just put it in general. So for that I have to do row set of R, and similarly when I put it in that row set, I have to also say within the corresponding row set, and I will just continue, and this will keep on checking through each iteration in which set it corresponds to using this R. Similarly, we have to do the same thing for our columns that we have. So I will say if column sets of C dot has the value that you are interested in, then something is wrong, and you just return false. That means you have already encountered it. And then for this column set, you will just say add the value that you have received. Now we covered this row sets that we have. We also covered the column sets that we have. Next is the box sets that we want to cover. And for that, first thing I need to know is which box I am looking at. And to find the index of the box, what I'm going to do is something like this. Index of the box is going to be math.floor row by 3 star 3 plus math.floor column by 3. And what this is going to do is that it's going to give me the corresponding index which I am looking at. What I mean by that is that, let's say you are in this box that you have here. Now within this box, the row is going to be, let's say, at this element which you are looking at here. It's going to be, row is going to be 8 and column is going to be 8. Now I want to know which box this is. What I can do is, as we said here, math.floor row by 3 star 3. So we'll say row by 3, which is going to give me 2, and I will multiply 3 by it. So it's going to be 3 2s are 6. So this is 2. 2 into 3 is going to be 6. So it's going to be giving me this 6, plus I will say for this corresponding column, I will say 8 by 3. So this is also going to be giving me 2 here. So this is 2 and this is 6. I will add this 6 and 2, and 6 plus 2 is going to give me 8, which is going to be the index of this corresponding box, because the index starts from 0. So this is 0, 1, 2, 3, 4, 5, 6, 7, and this is my 8th box that we have here. And having that in mind, let's proceed ahead. So we find the index of the box that we want to correctly check against for the set, and then I will do the same thing that I did for columns and my rows. I will just say if the box set of that corresponding index has the value. If it has it, that means you have already encountered it and this is not going to be a valid Sudoku. And if you have not encountered it, then we are just going to be adding that value in the corresponding set that we have within that box. And that's pretty much it in terms of implementation that we have here. And we will just keep iterating and towards the entire length to try to figure out if it fits or not. And here instead of set, I will say sets here. This will have the corresponding index that we are looking for, and we will just complete the execution here. We will skip if you have encountered a dot. Otherwise, we will check for our rows that we have, our columns, and our boxes that we have. So all the three criterias, and that's pretty much it in terms of implementation. Now, in terms of time complexity, it's going to be in best case big O of 1, and in terms of space complexity, it's going to be big O of 1 as well in the best case. Why? Is because n is constant and we're going to go in this loop for this specific n, so that is also constant. And this each check that we are doing, so we are doing a check for dot, we are doing a check for rows, we are doing a check for columns, and we are doing a check for boxes. So it's going to be big O of 1 each of them. So big O of 1 plus big O of 1 plus big O of 1 and big O of 1 4 times. So it becomes, in best case with n being a constant, it just becomes big O of 1. But in the worst case, wherein you can have a high number for n, then it will be, instead of big O of n, it will be big O of n square, because we have a nested loop here. So in worst case, it will go to big O of n square. And in terms of the space complexity also, in the worst case, it will go to big O of n square. So we also covered like the best case, which is going to be big O of 1 constant. And in worst case, when you have a high number for n, then it's going to go through big O of n square. And that's pretty much it. Thank you for watching. Please like and subscribe.